up with our motto, let learning be a joy and teaching a pleasure. Here we are with a remote teaching and learning process to bridge the gap. Happy learning, students.
Hello students, today we are going to study Mathematics Part 1 of Standard 10th, Chapter number 2, Quadratic Equation. In this video, we are going to study the second method of solving the quadratic equation, that is by completing the square method. Few points has to be remembered for solving the quadratic equation in completing the square method. First one is, write the given quadratic equation in ax square plus bx equals to c. Till now, the standard form what we used to follow for solving the quadratic equation was ax square plus bx plus c equals to 0. In this type of sum, what we will do, we will try to shift the constant value on the right hand side. And the second condition is that we will make the value of a as 1. If already 1, so no problem. But if the value of a is not 1, we will try to make it 1. And then we will start solving with the help of completing the square method. Practice at 2.3, sum number 1, x square plus x minus 20 equals to 0. Here the given equation is there in the standard form in a form of ax square plus bx plus c equals to 0. In points to remember, we had seen the constant value, we will be shifting it to the right hand side, which can be written as x square plus x equals to 20. After shifting the constant value on the right hand side, we will make a point as point number 1. Now after this we will try to find out the third term, and the formula for finding third term is half into coefficient of x the whole square. Here the coefficient of x means the coefficient of a linear term. Coefficient of linear term is 1. Therefore we will write 1 upon 2 into 1 the whole square, which can further be written as 1 upon 2 the whole square, which will be 1 upon 4. Therefore the third term value is 1 upon 4. Now this value of third term we are going to add in equation number 1 on both the hand side, which will be written as adding 1 upon 2 on both the side of equation 1. What we will get? We will get x square plus x plus 1 upon 4 equals to 20 plus 1 upon 4. See on the left hand side of the equation, x square plus x plus 1 upon 4 is a square of x plus 1 upon 2 the whole square. And on the right hand side, after making the denominator same, we will get 81 upon 4. Now let us try to remove the square root. Taking out square root, what we will get? We will get x plus 1 upon 2 equals to plus minus 9 upon 2. Why plus minus? 81 upon 4 is a square of positive 9 upon 2 as well as negative 9 upon 2. Let us bifurcate both the values. It can be written as therefore x plus 1 upon 2 equals to positive 9 upon 2, or x plus 1 upon 2 equals to negative 9 upon 2. Now 1 upon 2 from both the equation will be shifted to the right hand side and will be written as x equals to 9 upon 2 minus 1 upon 2, or x equals to minus 9 upon 2 minus 1 upon 2. Here the operation what we are going to do is subtraction, where denominator has to be same. In both the equations denominators are same, so we can further solve it as x equals to 8 upon 2, which further will be simplified and will be written as 4. And in second equation x equals to minus 10 upon 2, which will be further simplified and will be written as minus 5. Therefore final answer we will get, that will be 4 or minus 5 are the roots of the given quadratic equation. Sum number 2, x square plus 2x minus 5 equals to 0. Let us start with the solution. X square plus 2x minus 5 equals to 0. Again the given equation is there in the standard form. We will try to shift the constant value from the left hand side to the right hand side, which will be written as x square plus 2x equals to 5. We had saved it as point number 1. Now we will find out the third term with the formula half into coefficient of x the whole square. Here the coefficient of x is 2. Therefore it will be written as half into 2 the whole square, where 2 and 2 will be cancelled, will be written as 1 square, which will be 1. Therefore third term equals to 1. Now this third term we are going to add on both the side of equation 1, which will be written as adding 1 on both the side of equation 1, we will get what we will get? X square plus 2x plus 1 equals to 5 plus 1. Again on the left hand side we got a value x square plus 2x plus 1, which is a whole square of x plus 1 the whole square equals to 6. Now taking out the square root, we will get x plus 1 equals to plus minus root 6, as 6 is not a perfect square of any number, which will be written as root 6. Now we will separate the positive and the negative sign. It will be written as x plus 1 equals to root 6 or x plus 1 equals to minus root 6. Again plus 1 from both the equation will be shifted to the right hand side and will be written as x equals to minus 1 plus root 6 or x equals to minus 1 minus root 6. Therefore our final answer will be minus 1 plus root 6 or minus 1 minus root 6 are the roots of the given quadratic equation. Sum number 3, m square minus 5m equals to minus 3. Let us start with the solution. In this equation, already the constant value had been given on the right hand side. So here only we will block it as point number 1 and then we will try to get the value of the third term by formula half into coefficient of m the whole square. Here the variable they had used is m, and therefore in formula we will write half into coefficient of m the whole square. Now coefficient of m is minus 5, which will be written as half into minus 5 the whole square. Further, which will be written as minus 5 upon 2 the whole square, which will give us a value of 25 upon 4. Means third term value is 25 upon 4. Now this 25 upon 4 will be added in equation number 1 on both the hand side. Adding 25 upon 4 on both the side of equation 1, it will be written as m square minus 5m plus 25 upon 4 equals to minus 3 plus 25 upon 4. Again on the left hand side we got m square minus 5m plus 25 upon 4, which is a whole square of m minus 5 upon 2 the whole square minus, now on the right hand side we will do cross multiplication. We will get minus 12 upon 4 plus 25 upon 4. Further it will be written as m minus 5 upon 2 the whole square equals to 13 upon 4. Now taking out the square root, on the left hand side it will become m minus 5 upon 2 equals to positive negative. 13 is not a perfect square of any number, which will be written with the sign of root 13, and at the place of denominator 4 is a square of 2, which will be written as upon 2. Again we will separate positive and negative terms, which will be written as m minus 5 upon 2 equals to plus root 13 upon 2 or m minus 5 upon 2 equals to minus root 13 upon 2. From both the equation, minus 5 upon 2 will be shifted to the right hand side. It will be written as m equals to 5 upon 2 plus root 13 upon 2 or m equals to 5 upon 2 minus root 13 upon 2. In both the case, denominators are same, so we can give a common denominator, which will further be written as m equals to 5 plus root 13 upon 2 or m equals to 5 minus root 13 upon 2. Therefore our final answer will be 5 plus root 13 upon 2 or 5 minus root 13 upon 2 are the roots of the given quadratic equation. Sum number 4, 9y square minus 12y plus 2 equals to 0. Let us start with the solution. 9y square minus 12y plus 2 equals to 0. Here constant value is given on the left hand side, which we will shift to the right hand side, and we will get 9y square minus 12y equals to minus 2. In points to remember, we had studied 2 points. First thing was constant value has to be shifted to the right hand side, what just now we did. And the second condition was a value we have to make it 1. Here the value of a is 9. We have to make it 1. How we can do that? By dividing throughout by 9. We will write dividing throughout by 9. We will get y square minus 12 upon 9 y equals to minus 2 upon 9. Now the linear term what we got, that is minus 12 upon 9 y, which can again be written in a simplest form as minus 4 upon 3. So now next line we will write y square minus 4 upon 3y equals to minus 2 upon 9. Here we had shifted the constant value on the right hand side, as well as we had made the value of a as 1. Therefore we will block this equation as 1, and then we will find out the third term by using formula half into coefficient of y the whole square. Here the coefficient of y is minus 4 upon 3, which will be written as half into minus 4 upon 3 the whole square. Now 2 and minus 4 will be cancelled by 2's table, and we will get minus 2 upon 3 the whole square equals to 4 upon 9. Means the third term we got, that is 4 upon 9. Now this third term will be added in equation 1 on both the hand side. We will write adding 4 upon 9 on both the side of equation 1. What we will get? We will get y square minus 4 upon 3y plus 4 upon 9 equals to minus 2 upon 9 plus 4 upon 9. On the left hand side, we got y square minus 4 upon 3y plus 4 upon 9, which is a whole square of y minus 2 upon 3 the whole square. On the right hand side, two fractions we got. They are like fraction, means can be solved and will be written as y minus 2 upon 3 the whole square equals to 2 upon 9. Now by taking out the square root, we will get y minus 2 upon 3 equals to plus minus root 2 upon 3. Next line we will write y minus 2 upon 3 equals to positive root 2 upon 3, or y minus 2 upon 3 equals to negative root 2 upon 3. Again, from both the equation, minus 2 upon 3 will be shifted to the right hand side and will be written as y equals to 2 upon 3 plus root 2 upon 3, or y equals to 2 upon 3 minus root 2 upon 3. Further, denominators are same, so we will write 2 plus root 2 upon 3 or 2 minus root 2 upon 3. Final answer we will write 2 plus root 2 upon 3 or 2 minus root 2 upon 3 are the roots of the given quadratic equation. Sum number 5. 2y square plus 9y plus 10 equals to 0. Constant value has to be shifted to the right hand side. We will write 2y square plus 9y equals to minus 10. One condition we did. The second condition was a value should be 1. Here the value of a is 2. So again we will do dividing throughout by 2. We will get y square plus 9 upon 2y equals to minus 10 upon 2, where constant value again written in a simplest form and will become minus 5. Therefore next line we will write y square plus 9 upon 2y equals to minus 5, and we will block it as equation 1. Now we will find out the third term with the formula half into coefficient of y the whole square, which will be written as half into 9 upon 2 the whole square, which can further be written as 9 upon 4 the whole square equals to 81 upon 16. Now the third term we got, that is 81 upon 16, which will be added on both the hand side of equation 1. Adding 81 upon 16 on both the side of equation 1, we get, now what we will get? We will get y square plus 9 upon 2y plus 81 upon 16 equals to minus 5 plus 81 upon 16. Again see the left hand side, we got y square plus 9 upon 2y plus 81 upon 16, which is a whole square of y plus 9 upon 4. And on the right hand side, we got minus 5 plus 81 upon 16, where we will do cross multiplication and we will try to make its denominator same, which will be written as y plus 9 upon 4 the whole square equals to minus 80 plus 81 upon 16, which can further be written as y plus 9 upon 4 the whole square equals to 1 upon 16. Now taking out square root, on the left hand side we will get y plus 9 upon 4, and on the right hand side we will get plus minus 1 upon 4, which will further be written as y equals to 1 upon 4 minus 9 upon 4, or y equals to minus 1 upon 4 minus 9 upon 4. In both the equation denominators are same, so further it will be solved and will be written as y equals to minus 8 upon 4 or y equals to minus 10 upon 4. Again will be simplified and will be written as y equals to minus 2 or y equals to minus 5 upon 2. Therefore final answer we will write minus 2 or minus 5 upon 2 are the roots of the given quadratic equation. Sum number 6. 5x square equals to 4x plus 7. Let us start with the solution. 5x square plus 4x plus 7. Here the linear term and the constant value is given on the right hand side. Out of both, linear term has to be shifted to the left hand side and will be written as 5x square minus 4x equals to 7. The second points to remember was the value of a should be 1, and here the value of a is 5, which will be written as dividing throughout by 5, and we will get x square minus 4 upon 5x equals to 7 upon 5, and this equation we will block it as 1. Now we will find out the third term of this equation, which will be 4 upon 25. Now adding 4 upon 25 on both the hand side of equation 1, what we will get? We will get x square minus 4 upon 5x plus 4 upon 25 equals to 7 upon 5 plus 4 upon 25. On the left hand side, we got x square minus 4 upon 5x plus 4 upon 25, which is a whole square of x minus 2 upon 5. And on the right hand side, denominators are not same. First we will try to make its denominator same. Therefore the next line will be written as x minus 2 upon 5 the whole square equals to 35 upon 25 plus 4 upon 25. Now on the right hand side, denominators are same, which can be added. The next line will be written as x minus 2 upon 5 the whole square equals to 39 upon 25. Now taking out the square root, on the left hand side it will be x minus 2 upon 5. On the right hand side, at the place of numerator we have 39, which will be written with the root, as 39 is not a perfect square of any number, and denominator 25 is a perfect square of 5, will be written as 5. Therefore our next line will become x minus 2 upon 5 equals to plus minus root 39 upon 5, which can further be written as x minus 2 upon 5 equals to positive root 39 upon 5, or x minus 2 upon 5 equals to negative root 39 upon 5. From both the equation, minus 2 upon 5 will be shifted to the right hand side and will be written as x equals to 2 upon 5 plus root 39 upon 5, or x equals to 2 upon 5 minus root 39 upon 5. In both the equation, denominators are same, which will be written as 2 plus root 39 upon 5, or x equals to 2 minus root 39 upon 5. Therefore our final answer will become 2 plus root 39 upon 5 or 2 minus root 39 upon 5 are the roots of the given quadratic equation. In this video, we completed practice set 2.3, which was solving a quadratic equation by completing the square method. I hope you all had understood practice set 2.3, solving the quadratic equation by completing the square method. Thank you.